Great, thank you very much for coming to this session. So I am Miklós, and this is my colleague Krisztián. And Krisztián, we started working together before we knew that research software engineering is a thing. And so we spanned that spectrum. I think I'm going to give you the researcher perspective. I'm an economist, and Krisztián is a software engineer. So you'll see both perspectives on this tool. So imagine, so how many of you are academics who get excited by publications? Okay, so bear with me for suppose that you get good news from a journal that we really like your paper, but you have to make some revisions. And so that's insanely good news for an academic. Okay, I am at least not rejected. But they say, okay, you have 1 week to do all of this. So the reviewers are concerned about your data. And they really liked your figure 1. It makes your point very vividly, but there's some concern about the data. So maybe you should get new data and redo the analysis and submit, resubmit within 1 week. And so then you start scratching your head. Okay, so this is great news, but I submitted this research months ago. If you're an economist, it could have been a year ago, and particularly slow. And so you might be wondering, who exactly did that data cleaning part in the research team? They might have left since then, or completely different. The data format could have changed. We have updated our statistical methods because you have learned new stuff in 6 months. So the first question you come up, okay, so I have this figure 1. How do we actually exactly reproduce what we did submit to the journal? But that, so you work reproducibly, right? So okay, your figure 1 is produced by some code from some data. And so you follow best practices. So code is under version control. Say git. Great. You may even have tagged the version that you actually submitted to the journal. Great. You can go back and, yeah, that's the version that we have. But what about the data? And okay, let's go one step back in that chain. And so that, luckily, is also the result of some computation. So there was some raw data that you downloaded from, or wherever you got it from, and then made some transformation. You might have been dropping countries from the analysis because they are outliers, or you apply transformation to the variables or other feature engineering details to your statistical model. And so again, you have some analysis data or research data is a function of the code that you had and the raw data that you had. So in principle, all of this is, you can just follow the chain of provenance, you walk backwards, and in principle, you can do all this, right? If you follow best practices at every step, you're good, right? But of course, a real world data pipeline is not only 2 steps, it looks more like this. And you don't see much, but that's the point. You will see a version where you can zoom in and see what these pipelines actually look like from closer up. But the idea is that you have tons of different data sets, different versions of them. So here the red means that those are kind of out-of-date versions that are no longer used. So we tell about the visualization features as well. It's quite complex. So it's not like that you're gonna one by one walk back and do this. So what is the broader problem here that we're trying to solve? So we think the data provenance problem is quite complex because you're using like multiple different data sets and combining them in different ways. There's frequent changes, so method change. I mean, if you're cleaning data, you're always learning something and updating your code every day. At least in our research team, we had this experience that people prefer using different tools. So some people are R enthusiasts, some work in Julia or Python or SQL, and all of this is in one project. And as I already kind of alluded to at the beginning, you might have a big team and people might live in an academic environment. That was actually quite often the case that, who exactly produced the data? Oh yes, they have went on to do a PhD in the US. Good for them, but now we have no idea how to reproduce that result. Maybe we had the code, but we didn't know like when it was last run and kind of what happened with the code afterward. There are, when we explored existing solutions, of course, Git, I alluded to, great for code, not really good for binary. You don't really want to put large binary files under Git. We've played a little bit around with DVC, data version control, which is like a Git-like interface to versioning data. It only versions data. For us, it felt too complex. But if you have experience with combining Git and DVC, it's probably good for you. It's a similar idea. We also explored orchestration tools. We have the pipeline, and we're going to do everything in the proper order. But so my main concern with that is that these are typically language specific. So you have like Airflow for Python or dbt for SQL pipelines. And so then you would force every member of the team to use the same language and rerun everything in that big tool. So for us, all of these were just too complex. We needed something much simpler. So what bead is doing, it's a command line tool that packages the code and the data together in an immutable snapshot. It's going to be a zip file with all the data dependencies declared explicitly. And that's basically one chunk in the big graph of provenance, but that's enough for what we need, and you can reconstruct the entire provenance if you like. So Krisztián will show you how this actually works in practice, and then at the end I will tell you a few words about our experience using bead the past couple of years in our research.
Yeah, I will use the keyboard like a normal. Okay, so the design is centered on integrity of data input and output. It must exist at one time on a real output together. We need to capture this. The second one is ease of use. It comes after integrity. It is actually pretty good, I think. It was affected with integrity at least one point because input must be immutable. So once we have some inputs, it must not be changed. And yeah, and reproducibility comes third, which you might expect to come first, but it's not, and it is only an approximation. So why we capture state, but it might not be the state that is really meaningful. So there is user responsibility here as well. The inspiration is for publishing and the way we understand story. So it's a sequence of events, and there is an end of it. It's important, so it shares this with the project as well. There is goal in a project. Something is taken from book publishing, like the identifiers. They are not the same, but we use identifiers internally to refer to other stories or beats. Yeah, and one more thing about stories. These are not exact things usually as we present them. But in this case, in data stories must be, so computation stories must be, so we are using scripts, and scripts doesn't have parameters like tools. So yeah, you will see it later, but the idea is not to call something Python script name and give it some parameters, because that's good for documentation, but not good for capturing capturing this computation. The demo will be around this theme. So there is a conference session list. People talking about certain things, and we are the conference organizers and want to classify them by title into separate tracks or something like that will be used for making tracks. So we have a list of sessions with authors and talks. We have some rules to match the session titles. We have an output with a potential track ideas. So we have some setup and preparation. There are certain files that will be used for this demo. This will be included in the computation, so you will see them first, but these will be used. Next, we will have to have some working directory. So this, on the screen, you will see three parts. The top will be terminal, window, commands will be executed. And below them will be a working directory, how it looks like. It will be a directory tree, and we will work from this here. Next, we will need some place to store the computations. And we will create one such directory. And if you refer at the bottom right, it will be also directory B. And this is our first bead command. So these are our boxes where we store them. They have a name and they have a storage directory. This is the way to bead box add demo. Demo is the name of the box and the directory to use it. And yeah, we can list and the bead system knows about. I say bead system, it's not really a system, it's command line to enter is a configuration hidden in some config directory on the user home. Yeah, and we will work with first computation. It will be a very boring one because it will be a constant storing data. To make it, it will store the sessions, the CSV file for the sessions. With new sessions, we will create a new computation layout on the directory layout. With new session, go into this. We can see at the bottom left that we have input, output, and temp. These are directories. These don't look like there, but these are directories. And in this case, we don't have any code, don't have any input. We just have a output in, because it's constant computation, so we just copy over the prepared file, the output, and we want to save this computation and use it later to save it. Yeah, it's important for you to follow. So the data stored is this is the CSV file content for the first. See, there's a title and there is a speaker, and I think it's important to get to know it. So it's AI in healthcare, and Alice, she will have a program later, and also team building and workshop. Diana will have the other who will need some attention later. The other two sessions will be we save this computation on the left. It will get zipped up and stored in the reports. And actually, we are done with this computation, and we have a directory structure. We want to discard that and remove that from our system. And this is one strange situation. We are in a directory that no longer exists on the bottom left because it's discarded as well. So we need to exit. We cannot do anymore anything in that directory. Yeah, we do the same thing as before. We have a theme rules for the matching the session titles. We create a new workspace with new theme aliases. We enter it, copy over the prepared file into the output because this is also a constant. We look into this as before to get a feel what this competition will be around. So it looks like there is an alias. It's just a word or abbreviation or something that is inside title, and we translate it to something that we want to see in the output. So AI gets transformed to artificial intelligence. We need to map blockchain to itself, and Solar will be translated to sustainability. We save it to be used later. We need to also discard this workspace because we don't want them to call into our workspace, have more directories than we need. Actually, you can have more open, but it doesn't fit on this slide, so that's why I chose to remove all of them. And also, it's good to have a working area. Now comes the computation, which will take this to data, and we have to do some computation. So some code will run, and some output from input will be used, and output will be generated. So we create a new workspace with possible tracks, and we need to add these inputs to the system. And if happens with input out sessions, it will look at the inbox and search for the already stored computation sessions there. And you can see on the bottom left that input of the sections directory, and there is a sessions CSV, which was stored originally in the output of the sessions computation. We do the same with the theme aliases. It appears as well. Next, we will copy over the prepared computation, look into it, so that in magic happens. So we use here DuckDB to the Provenance Cifra script that can read CSV files and write CSV files, and perform a join on the two sessions and aliases, and select add the matches into the output. When we run it, so this script is important to have more parameters. When we run it, in the output, bottom left, the output appears, and yeah, so it's important. It is not tool script. When we look into it, we see that it indeed matches the titles to themes, and Alice as a is mapped to Alice Talk has mapped to artificial intelligence, but it could be healthcare as well. So it's that's one thing we can fix. And Diana didn't have any track assigned, so we might improve next that one. Yeah, and we want to also to save this computation and discard it, and also we want to fix this so that Diana has a team assigned, and the way to do this is to create new computations like the input, because we need new rows to for the join to produce different outputs. We do it with bead edit. Review is the one that has that extract the output as well, because we just want to rerun the computations, and output is something we don't want when preparing a new version. We look at this is the state originally we had, and we want Diana to have with the team building workshop to have some matches. So we will extend this list with the team building match to collaboration as well as workshop, and for Alice healthcare building match. So both of them will get new matches. So this is the output. We save it. You can see that new timestamp version appeared on the right. Yeah, and we use the this new input. We added the possible tracks. We have the script already there, but we don't have the inputs. When we say bead status, it will say that they are not loaded. We can load them with load and input load, input update. We want to update the team aliases rules. You can see that something happened, so it loaded something. You can see on the somewhat see from the timestamp that it's the second one that was loaded, not the first one, because it was updated. And we can load the rest, which is in this case the session. We run the script, the output appears, and when looking into it, we can see that it got fixed. So Diana got collaboration, signed, and Alice will have a stack. So at this point we discard this computation, because the next one is the visualization, and we already have too much for that. Actually, we will remove one of the from the existing computations. It's will be the sessions. The bead web is the command to view it. Color will do some freshness analysis, whether which you will see colored later in the image, and SVG will be that it is correct in this format. It loads we all have SVG file which looks like this. Actually, as you can see, there are 3 blocks, but sessions was deleted in the previous. So before, and it's red because it's not there, so it's a problem here. That's why it's red. Possible text has a problem, so that's really yeah, and green is the most updated version. Okay, so basically that's it. We have some internals, but it's just showing that we have some metadata besides the data and the code. Yeah, and we have some similar ideas from in Kevin notebook, mixtape, and orderly, which was presented last year, is very similar system to this. They have quite a good thought, and this is the source. And,
and we wrap up. So we've been using tool in our research lab, and as I mentioned, it's a big and heterogeneous research lab using a variety of data. And we've been using this for 8 years now. We have more than 600 different beads, and on average 2 versions each. And they have to be zippable things, so they are not enormous, but I think our largest is 23 gigabytes. So these are kind of reasonably sized data sets. And it kind of changed how we work, and in our research process, everything is a bead. So the first thing you do is if you get data, if you do a computation, you put it in a bead and save it in a bead box. One side product that I personally like very much is that forcing everyone to use relative path. Don't put in your Dropbox folder or any other absolute path because you have to work inside the bead folder. We don't often recompute everything. There are these long chains of provenance, but it's not rule that we could if it's necessary. So these are some of the links that Krisztián also mentioned. So check out the website, install it, check out the code. We're gonna be around, super happy to talk and answer questions. And also we are very grateful for support from the ERC for this project. Thank you very much.